Oh. Hey, ROS developers. Welcome again to a new ROS Developers live class. I'm very happy to be here today again and keep talking about using reinforcement learning with robots. Today, we are going to use only a single robot as opposite as the previous live class. But but it's going to be a lot of fun. And as always, you know how it works, but I'm going to repeat for the for the new people that is here. First, what we are going to do is we are going to learn about how to use a trained reinforcement learning network, how to use this into the robot. Because on the previous classes, we have been doing how to train that network, how to do it with this method, with this other, how to change with different robots. But what happens when you already have that neural network? So how do you use it? Okay, so that's what we are going to see today. And for that, we are going to use the ROS Development Studio. The ROS Development Studio is the tool that the construct, our company has built. And it's super interesting because it allows you to practice at the same time I am explaining. So you are going to see my screen and you are going to do exactly the same things as I am doing in real time with simulations, with code, execution, etc. Everything. How it's going to be that? Well, you need to have an account at the ROS Development Studio and it's for free. So you can go and have it. It's supposed that you should have it one before coming to the class. And then, so once you log in, I'm going to share with you a ROS project. So this ROS project, it's a complete ROS project that contains everything that we are going to use in the class today. It contains code, it contains simulation, it contains notebooks, data, etc. So you are going to have everything packed, and for you, it's going to work in the same way as it works for me. So you don't need to have any special installation in your computer. Even you can use Windows or Mac or whatever, and that's it. So you'll just keep attention into what I'm explaining and try to reproduce the same results. Okay, so just be concentrated on that. And in case that you have any question or any comment, whatever, any suggestion for the rest of the class, you can put it on the chat that is beside this video. You can see on the Hangout. I can see the people is getting into the class, and I see Lagan Kapoor, I see Andrew, I see the people are saying hi, Tech Dev, Rushir, RJ, Gianfranco, Hubert, Danny Das, hello everyone, and all the rest, because there are a lot of people today on the class. So welcome everyone, and let's go straight to the point. Remember, if you have comments, suggestions, jokes, put it on the chat beside the video, okay? Let's go for it. So the first thing that I'm going to do is to share the project, the ROS project, with you. So for that, I'm going to create this project you are going to see how it works. Okay, so let me share the screen with you. So I'm going to share my screen here. I was working already, because I was preparing. So that's the ROS Development Studio, but I'm going to go to my zone of ROS projects here, and this is the ROS project for today. It's the ROS Developers Live-Class number 36. For that, I'm coming here to share ROS project, and then I will copy this link and put it into the chat. So you can have this ROS project copied into your zone of the ROS Development Studio. Okay, due to problems in the chat of Hangouts, I have to shorten this link because it's too long. So I'm going to copy an actual shortened link there. So let me put it there. Now, everyone, you are there. You are on the chat. You can click on that link that I have just shared with you. And then you can start getting into the ROS Development Studio. And then Andrew is asking if this link is a virus. Okay, yes, good point, but no, not yet. Okay, maybe it will reach one day that we will be able to share virus and hack the robots based on ROS. Actually, I was in a couple of weeks ago, or 3, I was at the ROSCon conference, and there were a lot of talks talking about security in ROS too. So I recommend you that you go to the ROSCon website and you will see the talks. The talks are online and you can get as if you attended the ROSCon. So I recommend you because there were a lot of things. Yeah, so Andrew is keeping on the same joke. Okay, Andrew, let's go. So I presume if nobody is saying anything on the chat apart from Andrew, so I'm going to assume that it's working for all of you. So let's keep on. So let me share again my screen so you can see how we should proceed. So I presume that all of you are in this screen here, and something like that. I mean, of course, you will have different projects, not the same as I have. But anyway, you must have this project here. Let's open it. Press open ROSjet, open ROSjet. Okay. So here we go. And you should get this page here where the Jupyter Notebook, it's indicating here one file, the ROS Developers LIVE-Class number 36 file. So I'm going to wait a couple of minutes, not a couple, but 1 minute for everybody to be on this page so everybody can follow. And in case that you reach that page, just click on this notebook that is here, and then it will open. This is the notebook that we are going to do today. And I can see here, Gran is also there. Matiche is also there. Hi, Saif, Whiteley, Linda, Renan. Thank you, Renan, Ariel, saludos. And yeah, so, and Andy already mentioned. Okay, great. So let me know if you have any problem, okay? So I see Whiteley. Hello. Ah, you already said that. So, okay, Hubert, if you are concerned about the security of your data sent between devices, if the ROS, check out the Usernet. Yes, that's very good. So we are going to have a ROS Developers podcast with related to the Usernet in the next weeks. So stay. So Hubert is from Usarion. He's one of the creators of Usernet. Hello, Hubert. Okay, let's continue. So what is the subject of this live class is that we are going to, so we have trained already a DQNN, a neural network, and we want to use it. How do we use that? Okay, so in this class, we are going to see a couple of things more. So basically what we are going to see is how to save and retrieve an already trained DQ neural network. Okay, that is very important, because imagine that you are doing a training that will last for many hours. And then if it's training and then something goes wrong, the simulator crashes, I don't know, you have a bug in your code, and when you reach a certain number, it crashes. So imagine that you crash and you lose all your training. So you need to know how to save your current status of the neural network. And of course, if you want to save, it's because afterwards you want to retrieve, you want to load and keep training from that point, from the point that the system crashed. So that's one of the options. Another option is that because sometimes when you want to train a very, very difficult learning task, for example, for a robot, then you don't do a direct training of the neural network just on the task in one step, but instead you train the robot, you train the neural network on a simpler task. And then when this neural network has learned how to do that simpler task, then you provide a more complex task and train the already trained neural network, you train on that complex task, more complex. And then you keep doing these steps and steps until you reach the final goal that you want to the neural network to train. That's called a step training. So that's another case. So in those cases, you have to save and then change the task environment and then retrieve that one and train on the new task environment. And also, if you want to use the network on the robot, of course, that's the third case. So it's the case that I have been advertising this live class. And yeah, that's the basic one. Okay, that's the most interesting one. And here I have put some information about the ROS jets in case that you want to create your own. You can create ROS jets for yourself, for your community, for your students, for sharing your code to somebody else to demonstrate that your paper is not fake and that what you mentioned on the paper is actually working, or for example, to provide this work to the next one that comes to your lab. And then he doesn't have to be downloading Git and make it that compiles or doesn't compile, etc. Okay, let's go. So what are we going to do? We are going to use a lot of things that are already done and provided. So it's going to be a simpler class today. So for that, the first thing is to launch a simulation. So we are going to use this simulation that we created on the last live class. Well, we used on the last live class, and it's already provided in the ROS jet. Okay, so if you go here to tools, let me show you where it is. Okay, tools, and then IDE, select the IDE tool. Then, okay, yeah, so I was doing some other things here. But let me simplify this. You should have those four workspaces, sorry. And then there is one that is called the simulation. And here, inside the source, you have a Jing construct package that contains a launch and a world. So we are going to launch this simulation, okay? That is here indicated. For that, how do we launch that? We have several ways. The easiest one is go to simulations and here select launch file from the simulation workspace. Okay, select that, and then here on the launch file that indicates here launch file, select here the main rosbot.launch. Okay, so now the simulation is starting. Let me put it here besides. And it's going to start. Let's assume that it has already started, and we are going to have something like this, some screen like that. So keep me posted on the chat, okay? I'm keeping an eye to see if any of you have any problem. Now, what we are going to do is to get the training running. Okay, so this training is something that we already prepared on the previous live class. There was some small mistakes on the previous live class when we used the training for this ROS bot, because we had to tune some parameters in the configuration. That was pointed by Linda actually on the comments of the previous live class, and we have been playing with it and solving it. Very simple. Just have a look at not in the simulation workspace, but on the Karkin workspace. Here we have all the code. Let me simplify a little bit this because it's too complex. So here you must have the robot training package. This is the one that we are going to use for training the robot. And here there is a config file that is called the ROSbot params. You can open it, and here it is. So you will see, if you compare this one with the previous one of the live class, you will see that there are some small modifications. So I have decreased this linear turn speed, and I have increased the minimum range also. And there was also something, well, nothing very important, but that for that particular robot required to be modified. And if you find the differences and you want to ask me, it's not very important, but you want to ask me, please ask the questions on the video of this video beneath afterwards, and I will happily answer the question. Anyway, so we have the whole training. If you were at the previous live class, you can see that we created this configuration file for the training. We created a training file, a launch file for launching the training. And then there was this scripts directory that contains the actual algorithm for training. That's the one. If you open this one, the algorithm, then you will see that we have here the DQNN model here that is created with Keras. Here it's a sequential model, and it's created with here by Keras. Okay. So that's a model that we created, and then with all this environment that you have here in the robot training, we can start training our robot. So let's do it, okay? Let's do it, just for the sake of understanding the whole problem. And also because you have this working, so when you go home, you can start doing more experiments, changing the model, adding other type of environments, launching other simulations, etc. So that's nice to check that everyone can run it, the actual training. So let's go to tools and open a shell. And in this shell, let's launch the training with this command here. You can actually copy paste or type it directly if you want. And if you do that, then the robot should start training and should start moving and moving around. Okay. And there it goes. And there is a chart of reward that is being generated. In order to open it, you can go to tools here and see here that there is the OpenAI reward chart. So you can open it and then see how the reward of this robot is moving, is evolving as it learns more and more. And I can see that I have done another mistake in the code. It's not a big mistake. I mean, it's something that we should be doing together, but it's already here in the final code. It's, you know, it's super complicated to create this material for every live class. It's very complicated because we have to test that everything is working, and then it doesn't work, then we have to modify. And once we finish, then we don't know which part is the one that is, it has to be presented directly on the ROS object to you, or it has to be done. So we forget sometimes. So I forgot, that's my mistake. I forgot to remove the saving part here in the algorithm that I wanted to do it together. But anyway, that's it. So, I mean, it's not so important. Basically, it's more important the concept. Okay, so you can see that the robot here, apart from that comment, you can see that the robot is learning and it's getting this reward. Okay, let me leave it like that. And I presume that there are no comments on the chat, so I presume that you are trying to follow and you don't have any problem. Wait, okay, great. Then what's the next thing? So let's add the save and recovery functionality, of course. So how do we do that? Well, then first let's save the function, so the neural network that we have created. And for that, what we have to do is to add this function that we have here to the package, so I mean, as a member of the class of the neural network. So if you remember, on this process, on this learning algorithm, what we did was to create a DQN robot solver class. Okay, so that's a name. That's just a class that it has to inherit from nothing, actually, and then has some parameters. And then inside, it is where it creates the neural network here as sequential is a model that you can get from Keras here. Sequential is imported here. Okay, so then what we do is in this class, we are creating a save function. So in theory, you should copy this and add here to the code, but unfortunately, I messed it up and then I put it there and I forgot to remove it after I saved the final version for you. So it's already there, the solution, nothing too important anyway. And what do we have? So here we have the code, okay? It's a member of the class. So at any point, we can save the current model, and it receives as model name parameter. And this, what it does is to get the directory where it's going to save it, the model, and it's going to be saved on a directory inside the package, the robot training package. It's going to be saved inside the models directory. Okay, so as you can see, if you come here to the side, you can see on the robot training directory that there has been created a models directory. And if you open it, so if you do click, then you will see that inside it contains ROSbot maze, ROSbot maze.2 files with different extensions. And those are those files, they are defining the model that we are training. And what do we do? Well, as I explained, this part here is it's for providing this folder, deciding which folder is. Let me put bigger this here, the font, so you can see better. And let's put it here bigger. Okay, so yeah, so that's the first part. Then we decide which one is the model name, and that was provided as a parameter here. And it has two extensions, YAM and H5. Okay, so every model in this case has two parts, has to create two files. One is the YAM file. The YAM file is the file that defines the structure of the neural network. As you know, the neural network can have many, different inputs, outputs, different layers in the middle, different types of connections, recurrent, not recurrent, inside the neural network. So this YAM file that we are going to save is the one that contains the structure, how many layers and how they are connected, and how many neurons in each layer. So that's it. But okay, once we have that, then we need the actual knowledge, the actual learning that this is the weights of the connections of the neural network. For that, we are going to, the connections weights are the actual learning that is occurring in this reinforcement learning procedure that we are having here. So that's what is saved in the H5 file. In the H5 file, we get the weights of the networks. So we need both things. And then it's super simple because we got here the name of the file, and basically we save the models, and that's all. So by doing this and then this. Okay, so those are functions that are already provided by the Keras model. So they are functions that they're inside this model. How do they work? I don't know. I have no idea. It's just to serialize data into a file in a certain format. Okay, so that's it. That's what we do. You only need to know which ones are the functions, and basically is this. First, for the YAM, first we serialize and then we write as a normal file in Python. And for the HDF5 format file, then we use this function here. That's it. So that's the message that you are getting here all the time. Let me show you here. If I move this, you see that here we are receiving all the time save model to disk. And why is that? Because after each episode, we are saving the current model. Why you have to do that? Because it's very important, because otherwise you can lose your work if something goes wrong. So now my robot has learned up to generation number 20. If something goes wrong, I have my episode number 20. So after episode 20, if I lose my work now, then I will not, and I continue to train from that point. So it will continue from point number 20. So I haven't lost any knowledge except for the last episode training, whatever it was in there. So how do we do that? How do we save after each episode? Well, for this, we need to go to the algorithm, the actual the run algorithm that is here. And you can see here in the run, if you inspect this, that there are two loops, one for the number of episodes and another one for the number of steps inside each episode. So have a look at this, how it works. In previous live classes, we have been explaining that. So basically, every time that these steps are finished, then we go on this loop for the next episode. And here, is where we have added this saving function. And I'm calling it ROSBot maze. ROSBot, remember, is the name of this robot that we are having here. And then, so that's it for the saving. Okay, so let me check that I haven't finished anything here. Okay, yeah, so I think I explained a lot more than was here. Anyway, that's it. And here for recovering function. So for a recovering function, what we do is just the same, but in the opposite side. So first we get the package, the files names, and then we use, so we use this function here. Well, we open the YAM file first, read the data, and then we use this self model from YAM function. Okay, so this is provided by Keras itself as another function here, as you can see here. So this is the function that allows us to create the model from a YAM file. And then once we have the model that is loaded, then we can load the weights on it. So we can say, okay, each connection in the neural network has to have this weight according to this HDF5 file. And that's it. So it has nothing more, nothing more. So let's go. And the only thing that you have to know is, about those imports here. This is for the function of loading the YAM. And those two are for, first one is for IO in Python files, and this one is to have this function from ROS package. That is the one that allows us to identify the path of a given package. So where in the hard disk is this package and the whole path. So we get the whole path. It's very useful, this function, when you are moving around and you don't know. So inside the Python program, it's quite useful to get this trick here. So I recommend you that you have a look at that and use it. Then what else? So let's add this. As you know, I have added already the robot, the saving of the model. And then the only thing that it remains is that we have to load it. So for that, what I would recommend is that we put this, it depends on where, okay? So at present, this learning script, it's creating, every time that we start with the launch file, it's creating a new model here that is sequential. Then one thing that we can do is to decide if there is a parameter, for example, here that says load from file, then do not do this creation of the model, but instead load it. So that's one thing that we can do. Then by doing this, every time that you restart this program, you will start from the last saved model inside the models directory. Okay, so this is not what we are going to do because we don't have time to do everything, but what we are going to do is to go directly to executing a safe network. And in this case, we are going to need to create this load function. Okay, so how do we do that? Well, let's suppose that you have saved this model that has trained and have achieved already to save to learn how to move around this maze. Let's assume that this neural network has been already completely trained and then it knows how. So for that, I have included here into the package a couple of a model actually that it should be able to do it properly. But at this point in time, I'm not sure. I'm sorry, but I'm not sure because some things, so I don't actually know which one is the last one that have saved here. So, but don't worry, we are going to use it and we are going to try and see what happens, okay? So I have prepared one that was already solving this maze, for the Usarion, but I don't know if this one is the last one that I saved here, because I have seen this problem with the save function that is still here. Okay, so let's do one thing. Let's stop this training that we have here. Let's go to the shell. And let's stop this training, okay? So if we stop the training, that's okay. Now, it has saved these models here in the models directory. Let's remove those models. Let's remove it. Let's remove them. Delete. You can delete. Yes to all. And then take the models of the models example directory, the file, sorry. Then copy, and then go to models directory and paste. So by doing this, what we have done is to replace the saved model that we have been doing during this training by the ones that I'm providing you inside the ROS yet, just to test those, because I think that those are the ones that allow the robot to move around. And so we are going to test them. And for this, we are going to create another file. It's a different file. So if the file that we have here in the scripts is the ROSbot algorithm, is the one that trains the robot, we are going to create instead another file that we are going to call run DQNN. And this file is the one that just loads the models and executes on the robot. That's it. It doesn't do any training, anything at all. It just creates the model and uses it inside the whole OpenAI structure, of course, in order to move the robot around, but without doing any training. So how does it work? Well, basically, if you have a look at the code here, it's a simplified version of the previous one. And in future versions of the OpenAI ROS, it's going to be even simpler. But this is the current situation that we have. But as you can see, this algorithm is quite simple. It just has this basic initialization of the environment. And then it loads, using our function, it loads the models. That's it. And the load function is this one here. That is exactly the one that we had explained here above. Okay, so is this function here. Okay, so we have this that loads the file, and then we have the run. And inside the run, it's also very simplified because we don't have to do any learning at all. So the only thing that we do in the run is an endless loop forever. That what it does is first takes the model with the current state, and then gets the prediction. So what is the predict means what is the optimal action based on your current neural network that we have loaded. Then that's the action that we get here. And then we use this action to provide this action to the step of the environment, in the same sense as we were providing the action when we were training. And that's it. So it provides a reward and all this, but we don't need that because we are not using it for training. So the only interesting thing is that we get the next state, and then the next state has to be processed in a simple way. This process is the same function that we had here in the original training, okay? Is the pre-processed state, just configures in the proper format for the neural network, to provide that to the neural network. And that's it. That becomes the next state. Then it goes again to the loop, and it's provided here. A new action is generated. A new step is taken. So a new state is generated. And that's it infinitely. Okay. And when do we load this model? Well, that's very simple also. So when we initialize this class, when we initialize, instead of creating all the weights, etc., what we do is to call the load function. Okay, so this is here. So this is the opposite to this. This is the algorithm of training, and you can see the difference is that here we create the model, and then we create all the different layers and activation functions, etc. So that's not necessary because the files, the YAM file, it's already providing that. And also it gets the weights that we have trained. And that's it. There is nothing more. So let's do it. Let's create this file and let's try to see if this works. So for that, let's go to the IDE. Then inside the scripts directory, create a new file. That is going to be here, new file. Is going to be run _ DQNN.py. As always, use the same names I'm providing, because otherwise some copy paste will not work. So afterwards you can play with the names and change them when you understand everything. That's okay. But now follow this way of doing it. So here, let's, inside this file that we have just created, open it, double click and open it, and then come here and select everything, the content of this cell, copy, and then paste it here. That is the code that I have just explained to you. Then remember to save. Whenever you have this dot here, remember that there is a change. So you have to save in order to apply this change. Directly here on the menu, or Control S. Okay, great, we got it. Now we need to create another launch file, a different one. That is the one that is launching this file. So let's go here. Let me go. So it doesn't provide any launch name. Okay, so let's, for example, here in the launch file, in the launch directory, create a new file that is called, let's start running, for example, .launch. In this case, there is no name necessary. And open it and copy the code here of the cell. Copy and then paste, and then Control S, save. So what this file does is super simple. First, it loads all the parameters that are the same that we took during the training, and then so execute this new script that is the run DQNN.py. That's it. Basically, that's it. So let's go. So what we have to do is to launch this script instead of the previous one, and then we should see something like in this GIF. So let's do it. ROS launch robot training, and then it's a start running, yeah, .launch. And then if we do that and we put here the image of the simulator, then we should see here it says loaded model from disk, and then the robot starts moving with this model. And then it looks like it's moving on the proper way, but we'll see if it's this model, the proper one, because I'm not sure if I finally save the last one, the one that I use here for the GIF, to generate the GIF. And we have here a problem to start the next episode. Okay, oh, okay, so, no. Okay, so that's a problem. That is a problem, because in theory, it should not finish this. Okay, so yeah, so I see there is a problem here that we didn't devise, and it's the number of steps. It's the number of steps. We can go here, in order to change this, we can go here. Oh no, but we have to modify this robot, the task environment. So we have to modify the task environment. Okay, so that is a limitation. That is a limitation. So yeah, due that the situation that we are using the same environment of OpenAI for learning, but instead of learning, we want the robot to execute on an endless loop. the thing is that we have a maximum number of steps. And because of that, then the robot is going to stop the controller after this number of steps. We can modify here on the task environment of the robot, but this is not a very good solution, of course. So we have to figure out another solution for this problem. So basically, this is here in the task environment, here inside the Usarion file, and here the Usarion maze. Here we have a 100 time steps per episode, and we can put here whatever, but that's not the proper way of doing it, okay? Because otherwise this will affect afterwards into the training. So yeah, let's do it as a test, but this is something that we didn't think about. I actually didn't think, so it's a mistake. It's a mistake, but in any case, you see the way of doing it. You can see, so basically, we load this model, and then we take it, the output, as the ones that have to be directly executed into the robot. Oh, okay. So maybe it's not trying to step environment, which is currently done while the monitor is active. Okay. Okay, so yeah, so we need to look further into this problem. And this problem, I don't know, because it's not even that is close to the wall, so it's about to crash. Okay, so I don't know what is this, but I think that I have to check it better and do some tests. It looks like it has finished because it was about to crash then. Yeah. So, well, I have to look into detail. I'm sorry for that problem. And then Saif, it says that in the chat, it's only trained for the previous number of states. I don't understand what you mean. Saif, I don't understand. If you can clarify, please. But in any way, sorry, here there is another problem that has to be solved that is about this step environment. But the message looks like it has ended. So it has reached the final number of steps. So did I save this? Yes. Did I save? Yeah. So, okay. Yeah. So I have to look at it. So basically, that's the only thing that I wanted to show you today. And yeah, so we have some mistakes. But I hope that even those mistakes, you like this live class a lot. And if that was the case, please give us a thumbs up here in the video. Beneath the video, you can press the thumbs up, and that's super cool for us because it looks like it's showing that we are doing a good job, even if we have some mistakes. And if you want to be aware of when we are publishing new videos, subscribe and press the bell. There is a bell there when you subscribe. If you press it, you will be notified when we publish a new video, because we are publishing a new video every day from Monday to Sunday, every day. So you can get notified. And we have actually an academy that is called the Robot Ignite Academy, where we teach about ROS and many things related to ROS. So we have an in-depth course about using OpenAI with ROS, with more complex robots, with more complex tasks. And that's very interesting. I have put here a link in case that you are interested on having a look. But we have other courses like Python basics or C++ basics based on ROS. I mean, learning ROS with C++ or Python from zero, starting from zero. And our method, it always combines this simulations with code, with notebooks. It's always the same type of learning. You can get a 10% discount. I have put here a code that if you use it until tomorrow, it's available until tomorrow. So if you activate it, you will get a 10% discount. Then I would also to tell you that we are looking for interns. And maybe some of you are interested because you are learning ROS. You don't need to be experts in ROS for being an intern. You only need to be wanting to to learn more. So basically, you are going to do a lot of Gazebo simulations, ROS programs, ROS notebooks, and everything like that. And in case that you are interested, please send me a message here to this email, and we will go through the process of getting you as an intern. And finally, let me tell you that we have a podcast that is called the ROS Developer Podcast. And you can listen to it. Here I put the last one that is of this week, that is about ROS components for robots. So you can, in the ROS components, you can buy components that directly are working with ROS. So you are sure that they work with ROS. They have the drivers. They are going to communicate with any computer that has ROS without any problem. And we talk about that, how to build robots with this. Okay, so I'm going to finish here, but I'm going to answer your questions if you are there. So let me see if there are any questions here in the chat. And it says that Saif says, per episode, actually, I was struggling in testing the module. Thank you for this nice tutorial. Okay, so Saif, you say, we can change the number of stages in testing because we train on only 100 steps per episode. Oh, okay. So you mentioned, no, but that makes no sense because we are creating this new training every time. And the number of steps, it's depending on the task environment that you are creating. So we are creating a new one when we are doing the running. So when we create this new one, it will take the new parameter as that is 1,000 steps or whatever as the number of steps. So I had to go deeper into the code and check it because it's not clear there anyway. So that's anyway is an idea. So I will check it and let you know. And then Rikan says, hi, I have Intel RealSense camera. Show me how we can run, please. Okay. Yeah, that's very broad question. You need to show, to ask more concrete questions, because show me how to use the RealSense camera. So that's too broad. I'm sorry, Rikan, but I cannot do that. Please ask concrete question. Happy to answer that. Then Rohit says, can anyone share the ROSjet link again? I lost my internet connection. Yeah, you have this ROSjet that is up on the chat, Rohit, and you can go there and just click it on it. This ROSjet is available for one day. Yeah, so as long as you click on there before the day is end, so the next day, you can get the code again. Then RJ say, is DQNN much better than Q-learning? Yeah, well, it's a lot powerful because it's a very strong neural network, but it depends on the task that you want to apply. So maybe you have a very simple task and you don't need that. For example, we were trying to make a carpool simulation work with Q-learning, directly Q-learning table, implementation on a table. And it was impossible for us to do it with Gazebo simulation, okay? So many people is claiming that they have done it on a two-dimensional system that it doesn't simulate physics per se. But if you do it into a Gazebo 3D simulation with ROS controllers in the middle, so your velocities are not applied directly to the model, but to a controller, that this controller has a PID inside, and then it's generating the specific position or velocity or whatever for moving this with all the frictions and all that. Then for us, it was impossible to do it with a Q-learning. We needed to use a DQNN for that, and we achieve it. You can get the ROSjet. If you visit the page of rosjet.com, let me put it here, rosjet.com, you will see that there are a list of ROSjets there, and one is the one of the carpool with the proper learning, with the proper algorithm. So you can see, if you launch it, you will see how it starts learning, and after several generations, then it learns. So we achieve it by using this model, this DQNN. What takes the DQN as inputs for learning, like sensor data of the what exactly? So you will put inside the sensor data. In this case, is the laser data, but you can use, for example, a camera, and then put all the pixels as one input to the neural network. That's amazing. That's amazing, because you can have a very big, large image, and then the neural network will be learning from that amount of input that it's super big. And we are using this, for example, with if you are following us in Twitter, or we are creating a project that is reproducing the results of one of the famous papers on domain randomization. And for that, there is a camera that is capturing all the scene, and then it has to learn where a spam object, it's there in the table. What is the position among many other objects that are on the table? So what we are doing is taking a camera picture and then providing this to the neural network and make the neural network learn. And then on the output is providing the position, the X, Y, and Z of that object where it believes. So it has to train on that. Saif says, I'm really interested to know the reason. Thank you. Yeah, so I will look for that. What is the problem there? And then I will provide you to all you, not only to Saif, but to everyone, the solution. Maybe here beneath the video or on the next live class. Whatever it happens before. Then we have Hubert says, and try to look at this. Okay, real sense camera. Okay, thank you, Hubert, for supporting that question. Thank you. I was overwhelmed of the question by the question, so thank you very much, Hubert. Then Hubert says, full manual here. Okay, great. Thank you very much, Hubert. Conan, message retracted. Okay, I was about to read your message, Conan. Sorry. Screen Zrikan says, please give me tutorial on how run robot by using Intel RealSense instead of LEADER. Okay, so have a look at those that Hubert has provided. Okay, maybe you will get the answer there. Conan, again, is it possible to replicate the NLP models too, speech recognition, etc., here inside the ROS environment? Yeah, probably yes. I don't know which models are you talking to, but it's very likely, because this is just an example. It's a typical example of a neural network. If you have other models, they are very likely that they can be done here. About the speech recognition, okay, so one of the problems here in the ROS Development Studio at present is that we don't have access to the mics of the machine. This is something that we are going to solve in the future. So you can have the models there and execute it, but you will have to do it using WAV files, so files of audio, not direct audio that you speak on the mics. And then RJ says, is it possible to let multiple robots learn in one environment to get faster, good results? And that's a very good question from RJ. And yes, so actually, you can generate several simulations, and all the simulations are training their own robots and providing this learning into one single reinforcement learning policy. That is some feature that we have in our system that is called Jing computers. But at present, our Jing computers only allow to simulate in parallel as many computers as you want. You can launch as many with different parameters. So at present, you can launch different Jing computers, and each one will be testing a different file of parameters. This is very important when you are working with reinforcement learning, because you don't need the optimal parameters for your task. Then you have to do a lot of tests. And then if you have one single computer, then you are wasting your time there, because you have to, okay, stop, these are not okay, let's up a little bit more here, let's down this parameter a little bit more, let's try again, let's start again. With the Jing computers, you can generate several files of configuration and then launch all of them at the same time, and you will see all of them executing at the same time and getting you the results. You can see the charts of the different simulations and different trainings, and see which one is evolving better than the others. Actually, so I was thinking about creating a live class about that. The problem is that for those Jing computers, we cannot provide this access to everyone because it's a very expensive feature. So maybe we'll do something. Yeah, let's do something. Let's do something. Let's prepare. Let's do this. Let's prepare for the next live class. We are going to train different parameters in parallel using the Jing computers. But we cannot provide this access to everyone. So we are going to provide this to only to the first 10 people that write a comment beneath this video when it's finished. So when we finish this live class, it's going to be published, the video automatically by YouTube. And then you can go there and then say, hey, I want to be on the next live class for using the Jing computers. So for the first 10 comments on this, then we will provide free access for the class. So you can prepare. And the others, of course, they can come to the live class, but you will not be able to practice with the Jing computers. Yeah, let's do it like that. Yes, just like that. Yes, happen like this. Okay, many more questions. Let's do some more. Let's see. Is it possible to yeah, that's it. Saif, I'm interested to implement the idea of stacked frames with a robot camera and DQNN or A2C. If you plan to do a tutorial about that, I will be great. Okay, can you provide more information about that? About sticks frames with their, so can you provide more details about how you would like to have that? Please put it on the comments of the video. And definitely, we are interested on doing new tutorials on subjects of neural networks and training, because I think that, so we think that this environment is specifically good. So the future for intelligent robots is the use of simulations and training in the simulations. So any live class that goes on this direction will be happy. Don't worry for the people with a lower level of ROS or details, because we are going to intercalate this with other type of classes. Conan says, thank you very much. Thank you, Conan. Ru Shear says, is there an episode for making simulation from scratch? Yes, we have a series of videos that is Gazebo in 5 minutes. Look into our channel and you will see that series is going step by step in 5 minutes videos. Speedy step, thanks, lecture must go online. Okay, Speedy, thank you. And RJ, one last question. In my simulation with Q-learning, the steps are too fast for the robot. How can I make the algorithm wait for the robot? Okay, so I don't understand really your question, but in my simulation with Q-learning, the steps are too fast for the robot. How can I make the algorithm wait for the robot? Okay, so I think that you need some kind of synchronization. We are doing a synchronization here in the OpenAI ROS package. So I suggest you that you do that, because the OpenAI ROS package automatically does that. So it's actually stopping the simulation until the calculations are done, and then it restarts again when a new action is provided. So for the robot, there is like a continuum in decision. So it doesn't depend on the complexity of your algorithm. If you have a very complex algorithm and you want the process and then provide the action to the robot, so that by doing this stop, we are preventing that the algorithm takes a decision. This decision is performed by the robot, so it moves forward, then gets the observation, and while this observation is being processed, the robot keeps moving until this observation has generated a new action. But that doesn't make any sense, because this observation was not valid anymore. The robot has moved a lot, so that's why this kind of synchronization, I don't understand if you mean that. And but if this is the kind of synchronization, that's the one that this OpenAI ROS package is already doing that for you. You don't have to do it. So I recommend you. In case that this is not, please elaborate afterwards on the video comments. Where can I ask you guys questions to ROS and reinforcement learning offline? You can do it in here in the video, or if we have a forum that is, you need to have an account. Okay, that's what you were asking. Okay, great. So I nailed it on this one. So let me put for everyone, we finished the questions. I have to leave, sorry guys, but I'm going to put here the forum address. So let me check it because I don't know. I don't remember. Yeah, it's this one. You can ask us questions here on the forum. And in this forum, you need to have an account, but you can create a free account and on our academy, or on our academy. So you have to create a free account on the academy in order to access the forum. So basically, that's it. Gianfranco, thanks. Ricardo, thank you. Gianfranco, and thank you all for attending. Sorry for that error in the last minute, but I tested and I don't know why it happened. So let me have a deeper look in and give you an answer here in the comments of this video. Okay. Thank you very much, guys. Let's do that. Remember, the first 10 people that indicates their interest for the next live class with Jing computers is going to have access to the Jing computers and play at the same time as I am playing. For the rest, you will be able to play with the ROSjet and everything, but not in different Jing computers, just in one single computer. Okay, thank you guys. See you all around the world on the next live class. Bye-bye.